Okay. So yesterday we had seen two functions. That was, the first function was to create a node, and the second function was to add a node at the end. So today we are going to see the third function, okay, that is to add a node at the beginning of a single linked list. So let's see how we can do that. Okay, so looking at yesterday's linked list that we had created, okay, I'll continue with the same linked list. So what we are going to try to do is we are going to try to add a new node here. Okay, you can see the first node in the present example. The first node is starting at somewhere at the address 5000. So we are going to try to add a new first node before that. Okay, before the node which is pointed by Q. So we are going to try to add a new node here. Okay, so basically we are going to try to add a new node here before the present first node. Okay, so let's see how it is to be done. What is the programming required for that? So as usual, we start with our main function. Okay, so yesterday we had seen with a display function also. So next statement is we are going to add a new node at the beginning. Okay, so you can print some message and call the function to add a new node at the beginning. So when we call that function, this is the function that will be called. We declare one local variable of the type struct node, which is a pointer called as temp. Okay, one integer variable as num. Then we enter the data that is to be stored in the node, and we store it in the num variable. So suppose we enter the data as 30. Num will have the data as 30, which is to be stored in the node. In the next line, like I explained yesterday, we are going to allocate memory for a new node equal to the size of that structure members. Okay, and it is going to be pointed by some pointer temp. Okay, so let's do that. So we are allocating memory for a node. So there's some node. Okay, then there will be some address associated with that node. Okay, you can give any address, and like we mentioned here in this program, that node will be pointed by the variable temp. Okay, so let me put that. Now this is what happens in that programming line. Okay, so a node has been, memory has been allocated. The address of that memory is 9000. Okay, the node is having two parts, data part and the link part. Okay, and the node has been pointed by the address by the pointer temp. Okay, so now if I ask you what is the value of temp, the value of temp is the address of the node. Okay, 9000. In the next line, we store the data that were taken as input. Okay, that input was stored in the variable num. So we store that in the data part of the node. So what we will do, the programming for that is temp arrow data. Temp arrow data refers to this part of the node. Okay, the data part. So the data part I'll just highlight in yellow. So temp arrow data means the data part of the node. There we are going to store the number or the data that is stored currently in the variable num. So what is the number that is stored in that variable? 30. So we are going to store here 30. Basically, this is what we are going to do. This is what we had seen also yesterday. Okay. Then in the next part, what we want to do is, I told you always, okay, that Q pointer points to the address of the first node. Okay, now as you can see in this present diagram that we are having of the single linked list, Q is not pointing to the first node, but it's pointing to the second node. Okay, so we need to correct that. Okay, also another thing that is missing is there is no link formed between the first node and the second node. Okay, there is no link between the first node and the second node. So we need to also do that, form a link between the first node and the second node. So how we do that? We do that by using this line of code. What we need, if we want to form a link between the first node and the second node, what we need to do? We need to ensure that the address of the second node is stored in the link part of the first node. Okay, just pay attention, okay, what I'm telling you. So whenever you want to form a link between two nodes, you need to ensure that the link of the second node is always stored in the preceding node's link part. Okay, so the second node's address in this case is 5000. So this address needs to be stored here. Now how I access this portion, the link part of this node, using the pointer temp. So how you access it? This part of it is known as link. So I will access it is saying temp arrow link. So when I say temp arrow link means I am accessing the link part of this node. So there, what value should be stored? 5000. Okay, which variable now in this diagram contains the value 5000? Okay, so the variable, like we had discussed yesterday, that variable is pointer q. Pointer q contains the value 5000. That is the address of this node. Okay, so therefore when we are writing the program here, we say temp arrow link. Temp arrow link refers to this blue part. Okay, here in this node, temp arrow link should get the value 5000. Now which variable contains the value 5000? Q. So therefore we write here temp arrow link equal to q. Okay, when we do that, we will get 5000 here. Okay, we get 5000 here, and a link is formed between the first node and the second node, like this. A link is formed. Okay, the link is formed only because of this programming line. Okay, the link is not formed automatically. You need to write this programming line. Okay, now still one part is missing in our diagram. As you can see here, q should be pointing to the first node, but q is not presently it is not pointing to the first node. So we should make it point to the first node. So if you want to make it point to the first node, it's very simple. What is the address of the first node? 9000. Okay, 9000. Which variable contains that value 9000? Presently the variable temp. Okay, so that means temp is pointing to this node with the address 9000. So if I want to make q to point to this node, what I need to do? I need to give this address 9000 to the variable q, or to the pointer q. So how I do it? By simple assignment statement. Temp contains the value 9000, that is the address of this node. So I assign the value of temp to q. So when I assign the value of temp to q, q will get shifted from the second node to the first node. So this is that statement that I am telling you. I assign the value of temp, which is 9000, to q. Okay, so when I do that, what will happen to q? Q will no longer contain the value 5000, but q will contain the value 9000. Since q is 9000 now, q is no longer at this node. Okay, it will no longer be at this node, but q will be present here at the node with address 9000. Okay, understood? So because of this line, the q gets shifted. So now q is pointing at the correct place. Q should have been pointing always to the first node of a linked list. So now it is pointing to the first node of the linked list. So this is how you add a node at the beginning. Okay, so the moment I exit this function and I go back to main, since temp was a local variable, okay, temp will be deleted from the program. The moment you exit the function, since temp was a local variable, the lifetime of temp will be not be visible after you exit this function. So once I exit this function, I go back to the main function here. Okay, temp will get deleted from our program because it's a local variable. So the only variable that remains is q, and q is pointing to the first node of your single linked list. Okay, so this is how you add a node at the beginning. Clear? Okay. Now again, there's a display function. I had explained you this display function. It's the same display function yesterday that I explained, so I won't again do it. Okay. Next, let's look at how to add a node at the middle. So now I've shown you how to create the first node, how to add a node at the end of a linked list, how to add a node at the beginning of a linked list. So now let's see if I want to add a node anywhere in the middle. Okay, anywhere in the middle I could add a node. So let's look at that function. So that function for that is Addafter. So Addafter function is going to add a node somewhere in the middle of a linked list. Okay, let's see how to do that now. So when you call that function Addafter, this is your Addafter function. Okay, so again we have declared some local variables of the type struct node, temp and r, which are pointers. Declared some integer variables I, num and loc, location. Okay, so basically you're going to ask the user at what location, at what position you want to insert the new node. Okay, so you're basically going to take two variables as input from the user. The first is going to be the data that you're going to store, and the second is going to be the position or the location that you're going to store. Okay, so let's see. So first you take the input of the data. So say we are entering the number as 40. Okay, so say you are entering the value as 40 into the new node. Second, you ask at what position you want to insert the new node. So say I say the position is 1. Okay, I want to insert the new node at the location 1. Okay, then what I do, I assign the value of q. Okay, what is the value of q? Value of q is 9000. I assign the value of q, which is 9000, to the variable temp. Okay, to the variable temp. So when temp gets the value 9000, that means in the diagram what will happen? Temp also will start pointing to the node with the address 9000. Okay, so because of this line, temp also starts pointing to the first node of the linked list. Okay, basically this is what happens. Next, we use this for loop. Okay, we use this for loop to position temp according to this location that has been mentioned by the user. Okay, so temp will be placed. Okay, just remember what I'm trying to tell you. Okay, temp will be placed just prior to where the insertion is going to happen. Okay, so we are telling that we want the new node to be inserted at location 1. So basically what we are telling is we want the new node to be inserted here at first. So this will be my first node. Okay, this new node will be the second node because it will be inserted at the first position. Okay, then this will be the third node and this will be the fourth node. Okay, so basically when we are saying at location 1, it does not mean that it will be the first node of your linked list. Okay, so remember, it will be inserted after this location, whatever location that you are mentioning. Okay, so basically it is like insert after. Okay, so insert after this location. So when we are inserting the node, basically you are going to insert after this number that is mentioned in your by the user. Okay, so this will be the first node, the new node will be the second one, then this will be the third, and this will be the fourth. Okay, just to give you an idea. So this for loop that is there, what it will be doing? Basically, it will be trying to position temp prior to where the node is to be added. Okay, prior to where the node is to be added. So let's see how this for loop works. Okay, so I is initialized to 1. Then you check for this condition whether I is less than the value of LOC. As you can see here, the value of LOC is 1, value of I is 1. So 1 is not less than 1. So since it is not true, since 1 is not less than 1, this for loop is not executed. Okay, you do not execute anything inside the for loop because this condition is false. It's not true. So therefore, you come directly to this statement here. Okay, so this statement by now you must be understanding what it will do. It will allocate memory for a new node. Okay, and that memory for the new node will be pointed by this pointer R. Okay, so let's do that. So let's allocate memory for a new node. Let's call it as R. Okay, let's do something like this. Okay, and the pointer that will be pointing to this node will be called as R. Okay, again this node will be having some address. Give it some address. Okay, so there's a data part, there's a link part. Okay, now I'll not put colors. I think it should be enough for you. I think it should be, you should be able to understand. Okay, you no need to put colors every time. Okay, other you will get a habit of that. So we should be able to do it without colors. I think that should be fine for you. Okay, so we have allocated memory for a new node. The new node is pointed by R. And in our diagram, the new node's address is 5600. Okay, so if I ask you what is the value of R is 5600. If I ask you what is value of Q is 9000. What is value of temp? 9000. What is Q arrow data? 30. Q arrow link? 5000. Temp arrow data? 30. Temp arrow link? 5000. Similarly, R arrow data, right now nothing is there. R arrow link, right now nothing is there. Okay, just for revision. Now, as you can see in this diagram, this node has been allocated memory. So in the next step, let's store the data there. Okay, we have already taken the data as input. So we have decided that the data that we are going to store is 40. So we write the code for that. R arrow link equal to num. That means 40 will be stored here. Okay, 40 will be stored here. That is the line that we have written. R arrow data equal to num. Now very crucial here, what we need to do here. Okay, I can come to the chat box and check your answers. I want everyone to think and tell me. Okay, I will ask you the question. Okay, now you can see here, this is this is the linked list which is linked to each other. Okay, this is a new node which is not linked. Okay, so I want this as the first node, this as the second node, this one as the third node, and this one as the fourth node. Okay, so if that has to happen, what value should come here in the first node? In the address part, which address should come? Should it be 9000? Should it be 5600? Should it be 5000? Should it be 4800? Can you all answer in the chat box? See, I'll tell you again what should happen. This has to be the first node, this has to be the second node, this will be the third node, and this will be the fourth node. So if that situation has to happen, what should come in the link part here? Which address? Should it be 9000, 5600, 5000, or 4800? You can all answer in the chat, whoever knows the answer, or just even if you are wrong, it does not matter, just answer. What should come there? Correct. Okay, everyone is saying 5600. Okay, yeah, that's correct. you should be getting 5600 there. Okay, so when you get 5600 there, a link will be formed between the first node and the second node. Okay, now a link will be formed between the first node and the second node, but a link should also form between the second node and the third node. Okay, so this will be a second node and this will be a third node. So what value should come in the link part of R, the node pointed by R? What should come in the link part of R? What value should come? You can again answer in the chat. $5,000. Yes, correct. 5,000. Correct. Yes, correct. So now you need to do that programming, and that's it. You are done with your Addafter function. Okay. So let's see how to do that programming. Understood? No, we need to write only these 2 lines of code, and then we are done with the program or the function for Addafter. So in the next line, what we do is, okay, look at this line. Okay, R arrow link equal to temp arrow link. So let's look at what is R arrow link. R arrow link. Okay, here what we said, we should get a value here as 5,000. Just let me put it here. Okay, right now we are not, I'll just make it red. Okay, I should get here 5,000. Okay, now as you can see here, okay, 5,000. Is there any pointer pointing to this node here? Is there any pointer? You can see that there's no pointer pointing here. Okay, so I cannot get this 5,000. If there was a pointer pointing here, say for example, okay, let me just put here, just for example I'm putting, okay, it's not there, I'm just putting, say there was a pointer S. If there was a pointer S, now how I could have put 5,000 here. I could have put 5,000 in this portion here by saying R arrow link equal to S, because the value of S would have been 5,000. Okay, right? I could have written here, R arrow link equal to S. Okay, I could have written like that if it was S was there here. Okay, if S was there here, but right now we are not having this any kind of pointer here. Okay, so that means I cannot access this value. But can you see in this diagram, in the present diagram, 5,000 stored anywhere else? Yes, you can see that 5,000 is also stored here. Okay, this is the same 5,000. The address of the next node is stored in the link node here, in the link part of this node here. Okay, it's the same 5,000 address of the second node. Okay, so how can I access this part, this 5,000? By saying temp arrow link. Correct? How I can access this 5,000? By saying temp arrow link. I could have also said Q arrow link. Okay, I could have also said Q arrow link, but we always like to make use of the temporary variables. Okay, so this 5,000 can be accessed in 2 ways in the present situation. Okay, by saying Q arrow link or temp arrow link, but I access it by saying temp arrow link. So temp arrow link gives the value 5,000, which is this same 5,000 address of the second node. Where I want to store this value of temp arrow link, I want to store that value of 5,000 in R arrow link. Okay, so that is what we have written here. You can see that is what we have written. Temp arrow link, what value is there? 5,000. What is this 5,000? Simply we are taking, no, that is the address of this node. Okay, this address where we want to store here in R arrow link. So that is what we have done here. Temp arrow link, value 5,000, we store it in R arrow link. Got it? I hope you got it, what I'm trying to tell you. So let me make this as 5,000. So when you store this address, okay, when you store this address, what will happen? A link will form between this node and this node. Okay, a link will form like this. So now the second node is linked to the third node. Okay, link has been formed. Okay, because you put the address here 5,000. Now what we need to do? This first node, as you can see, is presently linked to this node. That is wrong. What we want it to happen? This first node should link to this node. Okay, so if that has to happen, like you all have already previously correctly told me, this value here 5600 should come here. Okay, 5600 should come here. So which variable contains the value 5600? The variable r. Okay, pointer variable r. So how you access this part of the node? Temp arrow link, okay, should get what value? This value. Where is the value stored? In r. Okay, so that is what we write here. Temp arrow link, okay, which is this portion here, should get a value of r. So that means this will become 5600. When this becomes 5600 here, it no longer points to the node with the address 5000. Instead, it will point to the node with the address 5600. So this will become your first node, this is your second node, this is your third node, and this is your last node or the fourth node. Understood? So this is how you add a node in the middle of a linked list. Is it okay? Did you get it? Okay.